Integrals part two. All right, so we took care of the Riemann sums, the basics, derivatives, and integrals. Now we're going to look at those initial value problems, differential equations, and volume. Some of those problems can get a little messy, but there are a lot of really easy points to be had on them, honestly. So let's go ahead and start looking at initial value problems. Remember, integrals will give a net change. So if you integrate a rate, then you're going to get the change in your original function over some time interval. So sometimes questions want to know a total, though. So all you got to do is, well, I know it changed this much and it started here. Add those together and you're done. The only thing that gets weird is like sometimes they're tricky, and instead of giving you an initial value, they give you the final value and ask for the initial. Well, you know, you ended up here. There was this much change, so just subtract the integral from the final value instead. So that's about as tricky as these problems get. So just make sure you're careful on that idea. It doesn't come up that often. Usually they give you the initial condition. All right, so let's look at this one. Let h be the function defined by h of x equals 1 over the square root of x to the fifth plus 1. If g is an antiderivative of h and g of 2 equals 3, what is the value of g of 4? Okay, well, I want to find g of 4. So what I'm going to have to do is I'm going to integrate h of x. What? Who did that? I'm going to integrate h of x from the two x values that I know. I know about 2 and I know about 4. Okay, that's going to give me the change in g on the interval 2 to 4. I want the actual value, so I'm going to do 3 plus that. Now if I look at the answer choices right now, I've got a pretty good hunch that it's D, just because they're 3 apart. And in fact, when you go into the calculator and do this integral and add 3, you get 3.152. So I've talked about that before. I talked about that when I was giving you multiple choice tips. Remember, you can kind of get the answer sometimes just by recognizing, oh, they're the initial value apart. So we can be mindful of that, but knowing how to do the calculus is always better. Okay, a rain barrel collects water off the roof of a house during 3 hours of heavy rainfall. The height of the water in the barrel increases at the rate of r of t equals vat feet per hour, where t is the time in hours since the rain began. At time t equals 1 hour, the height of the water is 0.75 feet. What is the height of the water in the barrel at time t equals 2 hours? Just like the last one, I'm just going to integrate from the two t values I know, the function r of t. That gives me the change in height. I want to know the actual height. So I had the initial condition. And when you put that in the calculator, you get 2.111. Easy as that. Find the integral, plug it in your calculator, add the initial condition. All right, this question is a little harder. This question mixes derivatives, the idea of extrema, and integrals all into one thing. So first thing I'm going to do is show you how to write a function that actually gives you the height of the water at time t. And then you're going to be able to use that, and that actually is a pretty useful skill to have. We're going to be able to use that to find the actual answer. So we want to find the minimum height of the water during the time period 0 to 24. Just like in that last one, then the integral's 1. I'm finding a minimum on a closed interval. That means I need to use the candidates test. So I know 2 of my candidates already are 0 and 24. So the integral, I'm going to need to find my critical points also, which I get by setting h prime of t equal to 0. Remember, you need to write this. Of course, we're going to go into the calculator for this because that function's a nightmare. But I need to write this down on my paper because considering that alone gets me credit. So that gives me t equals 6.261256. And you notice I didn't round this because I'm not at an answer yet. I need to make sure that I can actually have as many decimal places as I want until I get to the actual answer. So now this is the other part I was saying. I want to actually create a function that gives me the height at some time t. So remember, I'm going to integrate the rate, right? H prime, I'm going to take h of t is equal to the integral of h prime of t. Now, I know about t equals 0, so that's going to be one of my bounds. The other bound is just going to be t, because then I can put any time I want into it. So that looks like a 7. Just erase the whole thing because it doesn't look very pretty. So now I can put any t I want. I can get the change in h for any t value I want. Now, again, this is just the change in t. I want to find the actual height, the change. I don't want just the change in height, I want the actual height. So all I got to do is add this initial condition, which is 25. I like to put a little bracket around this so I don't get confused. Okay, so that will give me the height at any time t. So now I just need to make a table. Go 0 to 6.26126, just because I ran out of room. And then 24. Now I just need to do all these integrals. So when I integrate from 0 to 0, I don't need the calculator for that. That's going to be 0 plus 25 is 25. Now I do need to go into my calculator and get these other ones, so I'm going to pause while I do that. Back with some answers, plugged them in my calculator. It looks like this right here is the minimum. Now remember, this table right here is justification enough. I think that this h of t skill is very useful. I know I've seen some FRQs where they ask you to give an equation for an equation involving an integral that gives the height or the amount at any time t. So this is a useful idea to have. Just to recap what we did, we knew we had to do the candidates test because we needed the minimum on an interval. So we found a critical point by setting the derivative equal to 0. Then we made ourselves a function that gave us the height at any time t that we wanted. That's the underlined function. And then we just made a table of values and found out that that was the minimum. And we did use our calculator to get those h's. Cool. Now, the line tangent to the graph of h at t equals 16 is used to approximate the height of the water in the tank. Using the tangent line approximation, at what time t does the height of the water return to 25 meters? Well, I know I need y minus y1 equals m, x minus x1. Well, x1, well, really this should be t's, right? Because these are, this is all in terms of time, not x. So let's make sure I use the right variable. The t1 they gave us is just 16. So t minus 16. Now I need to use h prime of 16. And that's going to be my slope. And then y1 is the height at time 16. Well, luckily for us, on the previous slide, we found out that this would just be h of 16 equals the integral from 0 to 16 for h prime of t dt plus 25. Remember, this integral gets done by itself. Okay, and pause for the calculator. Okay, made it kind of small, but there it is. Just plugged into my calculator and got those values. So that's the first thing. Now it says, using the tangent line approximation, at what time t does the height of the water return to 25 meters? So I want to plug in the height is 25. I don't want to plug in t is 25. I want to plug in the height is 25. So that's going to look like 25 minus 23.49607 equals 1.19562 times t minus 16. Now all I got to do is solve for t, and you know what that means. I'm going back to the calculator. I'll be back in a second. Look at me just casually writing t equals 17.258. Okay, let's look and see what's next, guys. Differential equations. These show up almost always on the exam. Easy points are to be had even if you have no idea what you're doing, because I know every one of you can separate the variables. I am strongly confident that every one of you can anti-differentiate and add c. Plug in the initial condition to find out what c is. The hard part of this is solving for y, and it's only one of the 5 points. So do what you can. I know there are parts of this that you can do. Just be careful with your algebra. It's really, really manageable, honestly. Slope fields are a thing here too. I recommend just checking a few points by plugging into the differential equation. If you see there are horizontal slopes, so slopes of 0 on there, figure out what the pattern is there and why those are occurring, and that'll be helpful too. So, which of the following is the solution to the differential equation? dy dx equals y secant squared x with the initial condition y of pi fourths equals -1. Now, I think this is a pretty hard multiple choice question. Seems a little unreasonable to me because I know in the FRQs they offer you way more points to do the same thing, but that's all right because this is still a skill we need to practice. So the first thing I'm going to do is I'm going to separate the variables. So I need to multiply this up, and I need to take that and divide it down. So this is going to be dy over y equals secant squared of x dx. So on an FRQ, you just earned a point. Just doing that. That's all you had to do. Just move the y's over and move the dx's over. Now I'm going to anti-differentiate. Antiderivative of secant squared is tangent. That earns you another 2 points. You get 1 point for each antiderivative. Now you get another point just for figuring out what c is. So I'm going to plug in that initial condition. It says y of pi fourths equals -1. So ln, absolute value, -1, equals tangent of pi fourths plus c. So that's 0 equals 1 plus c. So apparently c is -1. That gets you another point on the FRQs. Just plugging in and solving for c. Now I'm going to put that into my differential equation. So now I've got ln, absolute value of y, equals tangent of x minus 1. Now to get rid of ln, I'm going to have absolute value of y equals e to the tangent of x minus 1. Now this is the part that gets tricky. I need to get rid of these absolute value bars, but I'm not sure how. What I need to do is reference the initial condition. If I plug in pi fourths on the right-hand side right now, on the e to the tan of x minus 1, I will not get -1. So I just stick a negative sign on it. That's literally all you got to do. And I've also dropped my absolute value bars by taking care of the sign there. So it's not written exactly in the same form that we have, but B is the answer. Plenty of points to be had here. I'm about to do another example of it, but I hope you see there are lots of points for you to get. Oh, I'm not going to do another example. Oh, I guess I'm a liar. All right, well, let's look at the slope field. What I said before, I like to find where the slope is 0 because that's usually an easy place to figure something out. So this one's a little deceptive because you notice this is -3, which makes this -2 and this -1. So whenever y is equal to -1, then the slope should be 0. Also, I see on the vertical axis that it's also 0, so that's x equals 0. So now I need to look at these and determine which of these are 0 when y is -1 and x is 0. So what I'm going to do is I'm going to factor these. Well, this is x times y plus 1. If x was 0, this would in fact be 0. If y was -1, this would in fact be 0. Okay, A is my answer. Don't have to go any further. If you wanted, you could go further just to double check yourself, but you'd be wasting your time this time because that just is it. Something that I don't have in here, but I just want to quickly mention, if for some reason on the FRQ they ask you to like draw a potential curve and they give you an initial condition, say like 3, 0, then I go find that point 3, 0. I just follow the train tracks. Something like that. Doesn't have to be perfect, just get the right idea. Start at the point that they give you, because if you don't go through that point, you're definitely wrong. And then afterwards, just kind of follow the road. All right, volume, everyone's favorite thing. If we're revolving around a horizontal line, or horizontal axis like y equals c, then we're going to use the disk method. So that's pi r squared. I pulled the pi out in the integral that you see on the paper, or on the slide, or video, whatever you want to call this. And then I did f of x minus c quantity squared. That's the radius. F of x minus c. And it doesn't matter if you do c minus f of x because you're squaring it. It's going to end up being positive anyway. Then the washer method. That's pi r squared minus pi r squared. So again, I factored out the pi. That's why it's outside the integral. And then I just do big R squared minus little r squared. So the only thing really here is just make sure that f of x is the one further from the axis of rotation. Make sure that one goes first. If you don't, you'll just be off by a negative sign, but it sure is nice to have our work correct for the AP graders. Then if we've got those known cross-section problems, like it says, region R is the base of a solid where the perpendicular cross-section is a square. That's usually what it is. It could be like an isosceles triangle, or it could be a rectangle. And the rectangles are a little weirder, but still not too bad. But you just find the area of the shape and integrate it. So that's not that bad. So let's look at this one. Solid is generated when S is revolved about the horizontal line y equals 5. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Okay, so I know I need to do pi r squared minus pi r squared, so I'm going to go out here. I'm going to put the pi here. I'm integrating from 0 to 4. Now I need to determine the axis of rotation is here. Should I use g of x first or should I use f of x first? Well, g is further from the axis of rotation, so it should go first. So this is g of x minus the axis of rotation, which is 5, squared, minus f of x minus 5 squared dx. That's all there is to it. They didn't even want us to evaluate this one. Just had to set it up. All right, last thing. Region R is the base of an art sculpture at all points R in R at a distance x from the y-axis. The height of the sculpture is given by h of x equals 4 minus x. Find the volume of the art sculpture. Okay, this is the rectangle idea. So we've got a rectangle whose height is h of x. Its base, it says the R is the base of an art sculpture. That means the base is g of x. So my integral is going to be the integral from 0 to 4 of h of x, g of x. And then I'm going to go into my calculator and get this answer. So that means pause. Just realized I'm not actually watching these videos, so I have no idea how stupid doing these random pauses is. But there's our answer. Okay, that wraps up the integrals video. Do particle motion next, and that'll wrap up AB's material. Again, these videos are not exhaustive, but these are the things that I notice happen a lot that we could definitely get stronger at to earn some good points on that exam we got coming up. Okay, love you.